Greetings, folks, and welcome to my video series on stats. My name is Martha Osei-Yaw. This presentation is a basic guide on t-tests for independent means for novice statisticians. Simply speaking, a t-test determines the means of different groups. In this presentation, you'll be able to determine when to apply a t-test for independent means. You'll also get an idea of how to compute and interpret the t-value. You will also explore some of the factors to consider when conducting a t-test for independent means. Here is some key terminology that you should become familiar with and explore further on your own. We have the mean, which is the statistical average. When discussing variables, you'll see the term independent. That's your cue that the variables, for example, are not related to one another. Inferential statistics is what we're currently working on, which means that we're trying to infer from the sample data and to make judgments about the probability. You'll also see the term variance, which means how far each number in the set is from the means. In terms of assumption, we will want to take a look at the normality of the data to see if the data is normally distributed. Now, this guide, which was developed by Salkin, provides a clear guide on how to determine the correct statistic for a t-test. And here are some factors to consider. If you're examining the differences between groups of one or more variables, this is something to take a look at. And also, are the same participants being tested more than once? So if you follow the area in blue on this flow chart, you're going to see if the same participants are being tested more than once, and the answer is no, how many groups are you dealing with? If you're dealing with two groups, then the t-test for independent sample is the correct statistic that you should be using. Now here's the formula for computing the t-value of a test. Now it gives you, like I stated, the formula for computing the t-value of a test if you want to run the numbers by hand. So the difference between the means makes up the numerator, and the amount of variation within and between each of the two groups makes up the denominator. Now these are 8 steps to follow to compute a t-test, and this was also developed by Neil Salkin. So step 1, state the null and research hypothesis. Step 2, state the level of risk associated with the null hypothesis. Step 3, select the appropriate test statistic. Step 4, compute the test statistic value. Step 5, determine the value needed for rejection of the null hypothesis. Step 6, compare the obtained value and the critical value. Step 7, if the obtained value is more extreme than the critical value, the null hypothesis cannot be accepted. And step 8, if the obtained value does not exceed the critical value, the null hypothesis is the most logical explanation. Now we're going to interpret and calculate the effect size. In order to do so, you will simply divide the difference between the means by any one of the standard deviations. Keep in mind that the effect size measures how two different groups are from one another. And lastly, I've included some guidelines based on Cohen's findings to help you interpret the effect size. The effect size gives you an idea about the relative position of one group to another group. For example, if the effect size is 0, that would indicate that both groups are very similar, and there may not be a difference in the distribution of scores. You'll also find an effect size calculator to help you get started. Well, I think now you're ready for some hands-on practice using SPSS. So tune into my next video if you'd like to see more.